Good day, my esteemed viewers out there. It's your favorite tutor, the formula. What I said before, the formula is an economist, mathematics, statistics, and a further maths teacher. So, on this afternoon's class, we are going to be looking at a very important topic in mathematics, which is known as the Pascal's triangle and the binomial theory. Now, what is a Pascal's triangle? Pascal's triangle was a concept that was introduced into mathematics by a French mathematician and scientist known as Blaise Pascal. So it provides us with a very compact and a very powerful way of expanding binomial expressions. A binomial expression is any expression that consists of two terms raised to a given amount of power. Now, how do we develop this Pascal's triangle? I am going to give you an introduction on how we generate those sequences. So just as the name implies, it gives us a pictorial view of triangles, which is made up of coefficients of a given binomial expression. Now, let us generate the triangle in question now. So we are going to start from 1. If I move to my right here, I'm going to have 1. Sorry, if I move to my left rather, if I move to my right 1. This will be used to expand a plus b raised to the power 0. While this second line will be used to expand a plus b raised to power what? 1. So if I move to my right here, sorry, if I move to my left again 1, 1 plus this 1, I put it at the center 2. If I move this one again, 1. So this will be used to expand a plus b raised to power what? 2, as you can see on the board. Now, if I move this 1 to the left, it's going to give me 1. 1 plus 2 is 3. We put it at the middle of 1 and 2. 2 plus 1 is 3. We put it at the middle of 1 and 2. Then this 1, we shift it rightward. So this guy will be used to expand a plus b raised to the power what now? Raised to power 3. Now, if I move this guy to the right, we are going to have 1. 1 plus 3 is 4. We write it here. 3 plus 3 is 6. We write it here. 3 plus 1 is 4. We write it at the center. Then this 1, we shift it rightward here. So this will be used to expand a plus b raised to power 4. Again, if I shift this man here, I'm going to have 1. Then I will keep on adding this. 1 plus 4, we are going to have 5. Then 4 plus 6, we are going to have 10, write it in their middle. 6 plus 4, we are going to have 10, write it in their middle. 4 plus 1 is 5, write it in their middle. And this one, shift it here. So this will be used to expand a plus b raised to the power what? 5. Now, so on and so forth. We can keep on forming an infinite number of terms. Now, if you see what we have gotten now, this is already what now? A triangle. This is already a triangle. So that is why we call this a Pascal's triangle. So these numbers you are seeing here now are used to expand expressions of this nature. They are used to expand expressions of this nature. Please take note that the Pascal's triangle can only be applied when the power of the binomial is positive, and it is positive and it is an integer. So when the power of the binomial is negative or is not an integer, then we cannot apply the Pascal's triangle concept. Rather, we are going to look at what now? The binomial theory. Now, we are going to take an example. Let us assume we want to expand something. Expand a plus b raised to power 3. Let's assume we want to use the knowledge of what we have got now to expand this particular concept. How do we do that now? It is very, very simple. I will just come here, a plus b raised to power 3. Look at what I'm going to do. So if the power is 3, now we take it from the, look at this man is used to expand a plus b to power 3. So these are the relevant coefficients here. So this coefficient, we are going to take it out and we are going to line it in this particular place. So when we do that now, we are going to have 1, 3, 3, 1. You just drop here. Now, the next thing we are going to do is how do we distribute this power to this particular A and B? It's very, very simple. So all I need to do now is, if I start with A will take the highest power and B will take the lowest power. By the highest power, we simply means the power of the binomial, where B will take the lowest power. By lowest power, we mean B will start from 0. So in each of the expansion, the power of the first one, the power of the first expansion will be the maximum power, where the power of the second one will be the minimum power. Then, if I am moving again, I will be lessening the first one by 1, and the second one will be gaining the power that the first one is losing, in such a way that when you add the powers of the term together, it will be equal to the power of the binomial. So having said that, now to expand this guy, we just write these numbers here. We write them 1, 3, 3, 1. Then all we need to do is to write this A here, A raised to power 3. Then we just write B, this B. Since A is power 3, now B will be what? Power 0. Plus, all we need to do again now is to write this A. A has power 3 here, A will turn to power 2. And B has power 0 here, B will gain that power that was lost. Plus, A has power 2 here now, so A will have power 1 here. And B will have what? Power 2. So that 1 plus 2 give us 3. Then here now, plus A has power 1 here, so A will have power 0 here, and B will have what? The power 3 here. So when we simplify what we have gotten from that particular place, we are going to have A cube, B raised to power 0 is 1. 1 times A cube is A cube, plus 3A square. B raised to power 1 is 3B, plus 3A B square, plus A raised to power 0 is 1. So 1 times B cube is B cube. So we are going to have this. Now, the learners are advised to do this. A plus B raised to power 6 is now what? The learners will do this for me. Okay, my esteemed viewers are there. I think this is the most you can take. In the next edition, or rather in the next video, we are going to see if the power of the binomial is negative or it is a fraction. What do we now do? That is where we are going to introduce the binomial theorem. Okay, have a nice day.